Algorithms are used in a wide variety of applications, from data processing to artificial intelligence. From self-driving cars to personalized medicine, algorithms are playing an increasingly important role in shaping our world. Algorithms can be used to optimize processes, improve efficiency, and even solve complex problems. What is an algorithm? Algorithms are the building blocks of computer programs and are found everywhere in our digital world. An algorithm is a word that actually dates back 900 years. There was a great Persian mathematician. His name was Muhammad ibn Musa al-Khwarizmi. Algorithmi is the Latinized version of his name al-Khwarizmi. It had become an English word by the 13th century. This is how the word algorithm originated. We all use algorithms everywhere in our daily life. In the modern world of computing, an algorithm means a set of step-by-step rules for solving a problem. Suppose you want to make a tea, then algorithm is: Step 1, boil the water. Step 2, add sugar. Step 3, add milk. Step 4, stir the tea. Step 5, drink the tea. In the computing world, you will find many different types of algorithms, each with its own purpose and application. Some common types of algorithms include sorting algorithms, search algorithms, and optimization algorithms. Some of the most popular and widely used algorithms include quicksort, merge sort, and Dijkstra's algorithm. The logic for an algorithm can simply be explained in pseudocode. It is a higher-level description of an algorithm. Pseudocode is a powerful tool for expressing algorithms in a way that is easy for people to understand, and it can be used to express algorithms in a variety of fields, including computer science, mathematics, and engineering. Algorithm design is a complex process that requires a deep understanding of the problem and a good knowledge of algorithms and programming. Let's try an example of a simple algorithm for searching a specific value in an unsorted array of integers. Here is a simple example of Python code for the program. This code prompts the user to enter a number and assigns the input value to the target variable. Then it uses a for loop to iterate through the elements of the numbers list. Inside the loop, it checks if the current element is equal to the target value, and if so, sets found to true and exits the loop. Finally, the code checks the value of found and outputs found the number if it is true, otherwise it outputs not found. You can see at the top that we have our unsorted list of integers. First, we search for the number 23, which is present in our list, and our program found the number. Then we tried the number 87, which does not exist in our list, and our program displayed not found as expected. When designing new algorithms, the efficiency is the most important aspect. Running time, memory requirements, storage space, power consumption, and data transmission are all important aspects to consider when designing the algorithm. The time complexity of an algorithm can be expressed with big O notation. It gives an idea of how the running time of an algorithm increases as the size of the input grows. The size of the input is usually denoted by the letter n. It is a standard notation that is widely used in computer science to analyze and compare the performance of different algorithms. For example, an algorithm with a time complexity of O(n) means that its running time grows linearly with the input size. An algorithm with a time complexity of O(n)² means that its running time grows quadratically with the input size. It's important to remember that the big O notation is an upper bound and describes the worst-case time complexity of an algorithm, but it can also be used to describe the average case or best-case time complexity. The main goal of the big O notation is to provide a simple, general way to compare the relative performance of different algorithms so that you can choose the best algorithm for a given task. The search algorithm we discussed earlier in our example is a linear search algorithm. Its time complexity is O(n) because it has to iterate through all the elements of the list, and the size of the input is the size of the list. This means that the running time of the algorithm increases linearly with the size of the list or array. It's efficient for small inputs, but it can be very slow for large inputs. It's better to use a more efficient algorithm like binary search, which has a time complexity of O log n. An algorithm with a time complexity of O log n is considered highly efficient because the number of operations increases only logarithmically with the input size. Remember, algorithms are a fundamental part of computer science and are used in a wide range of applications. Understanding how they work and how to use them effectively is an important skill for anyone interested in technology and programming. Thanks for watching. Please subscribe to the channel for future videos and updates.